So for the problem set 1, I'm going to model number 5, and you're going to do the rest. So we have sine of theta equals to 1. If you want to solve for the angle theta, what you have to do is you have to do the inverse sine of this 1 over here, and the inverse sine of 1 is 90 degrees, so theta equals 90 degrees, okay? And that's also known in radians as pi over 2. So these are both perfectly fine answers, 90 degrees or pi over 2. The next one that we want to do is number 9. So number 9 is similar to number 5, except in this case, sine of theta is not by itself yet, so we have to work to get it there. And the way we do that is the same way as if we just had a regular equation with an x value. All we want to do is isolate sine. So I see that there's a minus 2 plus sign, so therefore I can add 2 to make that a 0 pair, add 2 on this side, and you get sine of theta, and negative 1 combined with a positive 2 is 1. Okay, and again, just like in number 5, the inverse sine of 1 now will get you that theta angle. And luckily, that theta, so 90 equals theta. That theta is the same. Okay. The next one that we're going to work on is number 13. So I'm doing all of the first problems in these sets, and you're going to do the next ones. So number 13 is interesting because it says find all the solutions to each equation. Okay. So let's go about solving this. I have 2 minus sine, so I need to get that 2 away from that sine of theta. I'm going to subtract 2 because that creates a 0 pair. I'm going to do that on both sides, and I get 1 minus 2 is negative 1. And that equals, now keep in mind that that negative stays with the sign. I have not moved that negative yet, right? Sine theta. If you want to get rid of that negative sign in front of the sign, recall that negative sign is the same thing as saying negative 1 times sine. So I'm going to divide both sides by negative 1 to make that negative in front of the sign go away. Negative 1 divided by negative 1 is just 1. And keeping with our demo trends, 1 equals sine of theta again. And then we know that sine of theta equals 90 degrees. And that's because I did inverse sine of 1. Now, if you have theta equals 90, well, you can have an infinite number of answers to this, because if I add 360 to that answer, I'm going to be back at the same angle. Remember we talked about coterminal angles. So 90 plus 360 is also going to give me an answer. So 90 plus 360 is 450. So you could also say that 90 as well as 450 is an answer. And you could add 360 to that 450 and get another answer, right? So here's what we do. We say theta equals 90 degrees plus 360 n. And this piece right here gives us all of the solutions, because as n represents the number of times you go around the circle 360 degrees, creating another solution. So if you want all of the solutions, you go plus 360n. Okay, and just to see that in radians, if 90 degrees was in radians, that would be pi over 2. And then you would add 2 pi n to get all of the solutions. Okay. All right. And the last one, problem set 4, I'm going to do number 17. If sine of x equals negative 1, what is cosine of x? Well, if you have sine of x and you want to find cosine of x, shouldn't you find out what x is, and then you can plug it into cosine? So if I do the inverse sine of negative 1 to get x, so you use second sine in your calculator of negative 1, get negative 90 degrees. Now what I want to do is, since this is x, I can plug it into my cosine. So cosine of negative 90, and I type that straight into my calculator, no inverse. Cosine of negative 90 gives me 0 degrees, and that is what cosine of x is. So 0 degrees is cosine of x, and that is what they actually asked for, so make sure I'm circling that part of the answer. And that's it. So you should be able to do all the problems in all of these sections, giving the models for each first problem.